I'm going to go ahead and work through two more problems in section 4.1 from our book. These two linear function problems have to do with really a system of linear functions. And the problem I'm about to do, this one right here, is similar to problems 29 and 30 in the book. So let's take a look. Okay, so they give us our two functions. Here they are, f of x and g of x, and they ask us a number of questions. So let's just go through them. For what value of x does f of x equal 0? Well, let's go ahead and set f of x to be equal to 0 and solve for the x value where that is true. So I'd go ahead and say that 0 is equal to 4x minus 1. I add 1 to the other side, divide by 4, and I would say that the value for which f of x is 0 is when x is equal to 1/4. Okay, the next question. It says, for which values would f of x be greater than 0? So let's just set this into a little inequality that we need to solve. And we could say here, we want to know when is f of x, which is 4x minus 1, greater than 0? And if we solve this, we'd add 1 to the other side, very similar to solving the equation we did a minute ago. Oops, that's going to have to be a greater than sign there. And when we divide by 4, we would say that when is f of x greater than 0? When x is greater than 1/4. When x is greater than 1/4. Okay, the next question says, for what value of x does f of x equal g of x? So we're really finding, if you remember from previous algebra classes, we're really finding the common solution. If we were graphing this, which we will here in a little bit, we'd be finding the intersection point. But algebraically, to find this point, we would say, for what x value does f of x equal g of x? Well, it would be the answer to setting f of x equal to g of x and solving for x. So I'm going to go ahead and add 2x over to the other side. I'll add 1 to the right side, and it's when x is equal to 1. When x is equal to 1. Okay, now I have an inequality here. It says, what would be the case where x would cause f of x to be less than g of x, or less than or equal to g of x? And I'm going to go ahead and solve that problem over here. I just have a little bit more room, so I'm just going to go ahead and take that problem and work it out over here. So I'm going to say if f of x was 4x minus 1, I want to know when 4x minus 1 is less than or equal to negative 2x plus 5, which is my g of x function. Right? So I solve this, again, very similarly to a linear equation. I mean, it does turn out with inequalities, if you ever have to divide or multiply by a negative, you have to turn this sign around. But in this case, I think I could just add 2x to both sides. And I get 6x minus 1 is less than or equal to 5. I'm going to add 1 over here. And I'm going to divide by 6. And when would f of x be less than or equal to g of x? When x is less than or equal to 1. We're going to see that play out in a graph way here in a minute, but that would be the algebraic determination of the answer here, and this is when x is less than or equal to 1. Okay, next problem. It says, use the graphing tool to graph these equations. We're actually just going to go ahead and graph them here by hand, and then it says find the point that represents the solution to the equation f of x is equal to g of x. Okay, so we should get a similar answer to where we said that x was equal to 1 up here, but let's go ahead and try to graph these. And the first one is 4x minus, f of x is equal to 4x minus 1. So I'm going to go here at negative 1. I'm going to count up 1, 2, 3, 4, and over 1. Let me get a graph. Okay, and I think I'll label that. This is f of x. Okay. And then the other one was negative 2x plus 5. So I'll go up to 5. That's going to be my y-intercept. And then I'm going to count down 1, 2, and over 1. And I just so happen to land right on that intersection point I was going to try to solve for. And I got a graph like this for g of x. And it turns out the x value at which f of x and g of x are equal to each other is right here at 1. In fact, the total solution that would be, the common solution to both functions would be 1, 2, 3, 1, 3. The solution would be 1, 3. Okay, now, as long as I have this graph here, I'm going to go ahead and talk about a question that I think comes up in a similar problem, but it didn't happen to come up here in this list of problems that I had here. You remember when it asked me over here, it said, for what values would the f of x function be less than or equal to the g of x function? Well, take a look here. It's nice to look at this solution from the graph viewpoint. We already saw it algebraically. It was when x was less than or equal to 1. But let's look at the graph and take a look at where this would be on the graph, right? Where is f of x less than the g of x function? Or, where is the graph lower? Well, let's take a look. So here's my f of x function. It's actually higher here than the output of the g of x function. Over this way, f of x is higher than the g of x function. So where does it begin to become less or equal to? It looks like any x value from here where they're exactly the same or equal, and to the left. And right here, the x value that's producing the two functions' results to be equal is 1. Remember, that's 1. And anything to the left would cause my f of x function, for example, here at negative 1, f of x is lower or less than g of x. And that continues to be the case anywhere to the left of 1. See right here, g of x is greater than f of x, or another way of saying that is f of x continues to be less than g of x. So it makes sense that my answer was when x is less than or equal to 1. And so we see that on the graph as well as seeing it here algebraically. Right? When x is less than or equal to 1, we have f of x being less than g of x, or equal to if you include 1. Okay, let's look at one other problem. And this problem is like number 33 in the book. So it says here, we have, this time, they're talking about f of x and g of x functions, but they don't really state the functions. They give us a graph of the functions like we did here, but we did this problem in reverse. They gave us the function and then we looked at the graph. Here we're looking at the graph first, right? They gave us the graph. They didn't happen to give us the algebra that relates to these particular functions that produce the graph. But that's okay. I think we have enough information to answer the question. Questions. It says here, solve the equation f of x is equal to g of x. Well, when you take a look here, the common solution or the solution point where f of x is equal to g of x has to be where they intersect. And so that is exactly at negative 8, 6. At negative 8, 6. Okay. And then it says, or, they might just ask in the book, if you looked up the answer key, it might just be, for what x value would f of x equal g of x? And that would be negative 8. And here's the inequality, which that little discussion we had on the last problem may help us here with this problem here. It says, solve the inequality f of x is greater than g of x. Well, let's find the x values that would produce that to be true, make that true. Well, here we have the f of x function. Here we have the g of x function. And at what place is f of x? Now be careful, they didn't include equal here. but where, for what x values, would f of x be greater than g of x? Well, f of x is greater than g of x, it seems like over here, from this intersection point over. Now, not including that point, because we want to know where f of x is actually greater than g of x, we'd have to say that's true anywhere x is anywhere x is less than negative 8. Because at negative 8, they're exactly equal. When x is negative 8, they're exactly equal. So it looks like it's when x is less than negative 8, f of x is greater than g of x. I think that's about all I'm going to put on this video. I will go ahead and transfer the information over here. We asked for what value of x does f of x equal g of x exactly, and that was negative 8. And then it says for which values of x would f of x be greater than g of x. It says for every x in the interval, and maybe I'll state it in interval notation. It says it asked me to do that. So in interval notation, to restate x is less than negative 8. Maybe it'll help me if I just draw that on a number line. I find that sometimes number lines help me with interval notation. Well, to be less than negative 8 means that I would be here at negative 8. It did not include negative 8. Remember, we did not have an equal sign. So I'd have a parentheses there, and I pointed it to the left because I have to be less than that. Now, my lower limit for my interval notation will be negative infinity. I never reach it. So that also is going to be a parentheses kind of situation. So I think I'm going to state it this way. The x interval over which the f of x function is greater than g of x would be from negative infinity to negative 8.